Welcome to the lecture on discrete probability distribution. Already we know what is a discrete random variable. So now I am going to discuss about discrete probability distribution. A discrete random variable is a variable which take finite number of values or countably infinite number of values. So here xi is an discrete random variable. So if p of xi is positive and summation of p of xi is equal to 1, then the function p of x is called probability function in case of the discrete random variables. So now we'll see what is discrete probability distribution. If xi is a discrete random variable and the set of values xi and p of xi, I mean grouping all the random variables with the probability of that particular random variable is called discrete probability distribution, or also we can call it as a finite probability distribution, where p of x is called probability density function. We can call this one as pdf, or we can call this one also probability mass function or PMF, where x stands for discrete random variable. So now let me define a function f of x, and it is given by p of capital X is less than or equal to small x, that is summation the I ranges from 1 to x with the probability of the random variable xi. So this function f of x is called cumulative distribution function, or we can call this one simply as CDF. So next we will see what is mean, variance and standard deviation in case of discrete probability distribution. So mean is given by summation xi into p of xi. Variance V is given by summation xi minus mu whole square into p of xi, or we can take the formula like summation I xi square into p of xi minus summation I xi p of xi whole square, or also we can denote this formula like summation xi square p of xi minus mean square. And we know already standard deviation is nothing but square root of the variance. So now in this lecture we're going to learn about how to find the mean, variance and standard deviation for some discrete data. So here one example. The problem is find a mean, variance and standard deviation of the probability distribution given by the following table. So the data is like this. The discrete random variable xi is given by 1, 2, 3, 4, 5. Further, the probability of the random variable is 0.2, 0.35, 0.25, 0.15, 0.05. So now we will see how to find the mean, variance and standard deviation. Already we know the mean formula is given by summation xi p of xi. So if we expand this summation, the formula will be x1 p of x1 plus x2 p of x2 plus etc plus x5 p of xi. So since the data contains x5 and p of xi, we can take the formula till p of x5 and x5. So now I am going to replace the values of x1 p of xn according to the formula. We'll get the solution like 2.5. So uh, next is variance. The variance formula is summation xi minus mu whole square into p of xi. So according to the formula, I am going to subtract the random variable xi with the obtained mean, that is 2.5, and squaring it, and I'm going to multiply with p of xi here. So if we expand the formula, we'll get the equation like this: x1 minus mu whole square p of x1 plus x2 minus mu whole square p of x2, and so on till x5 minus mu whole square P of x5. So since mu is given by 2, mu is 2.5, I can replace the mu value along with the random variable and the P of xi values. The After simplification, the solution will be v is equal to 1.25. And we know the standard deviation, it is nothing but square root of the variance. It is given by square root of 1.25. So final answer is 1.118. So one more example. The problem is the probability distribution of a finite random variable x is given by the following table. So the range of x is like this: -2, -1, 0, 1, 2, 3. P of xi with respect to the random variable xi is 0.1 k, 0.2, 2k, 0.3 k. So from this discrete probability distribution table, we supposed to estimate the value of k. We have to find mean, we have to find variance, and also we have to find the p of x is less than 1, p of -1 less than x less than or equal to 2, p of x is greater than -1. So let me see how to find the value of k. Since the given data is probability distribution function, so it obviously satisfies the conditions p of x is positive only if k is positive, and summation p of x is equal to 1. So on expanding summation p of x, we can write like adding all the p of x values equal to 1. I can write it. So if I add all the p of x values, the equation will be 4k plus 0.6 is equal to 1. If I simplify this for k, I will get k is equal to 0.1. So in the same way, I can find the mean also. So mean formula is summation x into f of x. If I simplify this summation x into p of x, the value will be 0.4 plus 4k, I will get it. Since k is 0.1, I can estimate the mean value is 0.8 at k is equal to 0.1. Similarly, I can estimate the value of variance also. The variance formula is already we know, that is summation x minus mu whole square p of x. If I expand the summation, the formula will be x minus mu whole square p of x1 plus etc plus x6 minus mu whole square p of x6. So if I replace all the discrete random variable data along with obtained mean 0.8 and p of x values, the variance value will be 2.16. Along with this, we supposed to estimate the value of p of x is strictly less than 1. So since they are given p of x is strictly less than 1, the range of x will be -2, -1, 0. So now we have to estimate the value of p at this range -2, -1, 0. So according to the formula, we'll get p of -2 plus p of -1 plus p of 0. If I replace all this data from the table along with the value of k, that is 0.1, the solution will be 0.4. The next one is p of -1 strictly less than x less than or equal to 2. So here the range of x is 0 to 2. So p of 0, p of 1, p of 2, I will get it. So from the table again, if I replace all the data and summing it along with k is equal to 0.1, the solution will be 0.7. So the last one is p of x is greater than -1. So since it is greater than -1, the range of x will be 0, 1, 2, 3. So we supposed to estimate the sum of p of 0, p of 1, p of 2, p of 3. So if I replace the data from the table along with k is equal to 0.1, the solution will be 0.8. So in the next lecture, I am going to discuss briefly about continuous probability distribution and also about mean, variance and standard deviation of the continuous probability distributions. Thank you.